Hello everyone. In today's class, we are going to do three experiments. Experiment number one is about we have to first see the blink program. Then second, what we have to do, we have to go for the traffic light signal. And the third thing we have to do is we have to use RGB LEDs to control three colors of the LED at the same time. So at first, what we have to do, we have to go to create and we have to go to circuits. Once you enter this one, you'll be able to see this screen. So in this screen, you can see a lot of things are available here. You can see all the components are available at the right side, and whatever components you want, you can take it from here. So our experiment number one is, at first we are going to go for the blink program. So it's very simple. Just you have to drag it and drop it here. So you will be getting the Arduino, and this is just this is a serial connector actually. So first of all, we should know about Arduino. So this is the microcontroller which we have, and you are seeing this microcontroller is the brain of the system. There only inside this microcontroller only microprocessor, ALU unit, and different processing units are actually available inside this one. So this is the main brain of the system. This is the voltage regulator. This voltage regulator is actually responsible for regulating the voltage. For example, if you're connecting your laptop from this serial connector, here also some voltage will be available, and if you want, you can give the power supply from this power jack, that also is available, and there is a V in pin, input voltage pin. From there also you can power on the Arduino, but in all the cases the correct amount of voltage only should be reaching here. So to reach the correct amount of voltage, what we need a voltage regulator. This crystal oscillator is responsible for frequency management of the whole programming logic, and there are so many inbuilt things are also there. There is an inbuilt LED as well, and these are the transmitter and receiver pins. These are some digital pins, these are some analog pins, and these are some power supply related pins. So let's start the experiment number one, that is a blink LED program. That is the most basic type actually. So what happens, at first we have to go to the code and see what is there inbuilt already. So you can see that there is an option to go for block based code, that is very popular nowadays, but we prefer to go for text based codes. So you can see that in the program they have given you inbuilt program already. This is a C++ code. So you know that the syntax is actually word setup. You already know this one. That will be very easy. So what happens here is we have to pin mode function is actually used to declare which pin is input and which pin is output. So you know that in any pin can be considered as input or output. It depends on uh, our way of programming. So LED built-in is actually in different Arduinos. For example, you are taking an Arduino, LED pin is connected. Inbuilt LED is actually there. Same way, in different Arduinos, LED pin is connected in different pins. So we don't need to remember those. So for that, there is a command called LED built-in, wherever the LED is available. If you use this LED built-in command, automatically in that place the LED will start to blink. So that only there is inbuilt command, but we know that in our Arduino, pin number 13 is the inbuilt LED pin. So that we are going to give. Now, I think it's very easy for you to understand. Void setup part of the code is like it is used for assignment, it is used for declaration, it is used to run any part of the code just for one time. So these three are the functionalities of void setup part. That is, it will run only once. This is the loop code. That loop code means it will be running continuously. So in the loop part of the code, what we are declaring here, we already declared pin number 13 is the output pin. Pin number 13 can be input also, but it depends on that. Like if you have connected any sensor, you want to detect that any voltage is coming from the sensor or not, then you have to use it as a input pin. But here we want to connect an LED here, one LED here. So because of that only we are going to put it as a output pin. So at first, pin number 13 should be high. It means it should be on. Then after 1 second, this is actually in milliseconds. So 1000 millisecond means 1 second. So in 1 second, after 1 second, it should be pin number 13 should be off. Then again, it should remain off for 1 second. Then the same process will be keep on repeating. It's pretty simple and very easy part of the code. Now let's connect the hardware. So at first, what we'll take LED. So we'll take LED. So this is simple type of LED. This is a RGB type of LEDs. Here only one color will come at a time. Here you can get three colors at a time based on your program. So let's connect it. So you know that this is for most of the microcontrollers, always the output is 5 volt for most of the microcontrollers. So for 5 volts, 220 ohm resistor is actually useful, because for LEDs, the range is from 1.5 to 3 volts. In between this range only you can give the voltage. But the microcontroller actually gives 5 volt. So here what we are going to do, we are going to connect one resistor. So we'll connect the resistor. So we'll take this resistor. So this is brown, black, red. 1 in uh, 1 0 into 10 to power 2. So this is actually 1000. So we'll have to reduce it. For 5 volts actually we need 220 ohm of resistance. If the input is actually for example 12 volts, then we need 330 ohm of resistance. So we'll connect. Now one more thing is there. This is anode and this is cathode. This is cathode and this is anode. Anode means positive, cathode means negative. So this negative will connect directly with ground. And the color of negative is always black. So we'll change it to black color. Now pin number 13 will connect it to positive side of the LED. In physical LED also, the longer leg means that is positive and a smaller leg means that is negative. So for positive the color is red. Now you know that in pin number 13, 1 second on, 1 second off was there. So I will straight away run this code. Okay. So for 1 second it will be keep on, and for 1 second it will be off. Now let's change this. We'll try to make it a little faster. So let's go for 250. 250 means what? First you have to off this. 250 means what? 250 means quarter of the second, 0.25 second. So 250 and 250. Half second on, half second off. Now we'll start the simulation. So with this you can find that it will be going, actually it will be glowing a little faster, and at the same time you can see that inbuilt LED also is actually glowing in the same way. So that's the thing. This was the experiment number 1, pretty simple. Experiment number 2. So we have to go for experiment number 2, that was the traffic signal. So the same thing, the same circuit, we have to repeat it twice. Okay, so what we'll do, we'll make it a little faster and we'll make the same circuit again. Okay, so we have to go for again another resistor. We have to go for one more resistor, then we have to go for LED. We have to go for one more LED, and same we have to go for one more LED, and we'll connect. You know that ground is always connected with the ground. Okay, it is connected. Even you can connect in any ground. In every in this Arduino actually 3 grounds are available. Anywhere you can connect your this. But you have to make sure that ground is always represented by black color. Okay. Then positive. Positive will give to pin number. Okay. Then we have to connect it with red. And in same way we have to connect with 11. Okay. So now in pin number in traffic signal, what all the colors are actually available? Basically this is red. Then there should be green. So we'll click it and we'll change it to green, and we'll click this one and we'll make it yellow. Now what I want, like in traffic signal generally how it is there for 2 minutes, 2 minutes, 2 minutes, or 1 minute, 1 minute, 1 minute. So we'll not wait for that much long time. We'll simply change this to uh, we'll first make this to 220 ohms, so proper light will come, proper resistance will be there. This also true. So this time we'll make for 2 seconds, maybe 1 second, or maybe 1 second, that will be fine. So we'll go to code. So you remember that in pin number 13 what we connected? Pin number 13 we connected red. Okay. Then in pin number 12 what we connected? In pin number 12 we connected green. Then in pin number 11 we connected yellow. Okay, now we'll make it for 1 second. 1 second. So what we'll write it here? LED on 1 second, 1 second, red LED on, right? Then it will wait for 1000 milliseconds, and again here what? For 1 second, 1 second, red LED off. Okay. Now what should happen? First red LED, then after that what happens? Green, then yellow. At the time, two LEDs, they are never on in traffic signal. The same thing will repeat here. This code will repeat it again. So we have to give this 12 and this pin is 11, and then we have to see. You can see that one LED is getting on, off, on, off, on, off. But in traffic signal, what happens? In traffic signal, LED gets on, then once it gets off, another starts. So in the code, we have to do some changes. We'll make this LED gets on for 2 seconds, and once it gets off, immediately the another one starts. Okay, for 2 seconds. And once it gets off, immediately another starts. 2 seconds on and immediately gets off. Okay, and now we'll see what happens. Okay, so traffic signal actually works like this. So this was our experiment number 2. Now experiment number 3 is pretty simple. You can just add it like that. I'll just show you. For that we have to take the RGB LED. So you have to type RGB. Once you type RGB, this RGB LED will come. So in this you have to check which is cathode, which is anode. Red, cathode, blue, green. So cathode is this one. It means we have to connect ground here. I mean resistor here. So we will type RES, and here one resistor will take. And you remember for 5 volt we need how many ohms? So we need 220 ohm of the resistance value. That will connect straight away with the ground, and this is red. Red will be connected in pin number 13, and this is blue. That blue should be connected in pin number 12, and this is green. Green should be connected in pin number 11. Green should be connected in pin number 11, and this is the ground. Now you remember the code. What was the code? In pin number 13, red was connected, right? So in pin number 12, blue was connected. Now green was connected. Now we'll change this to blue. This comment is very important. You should always try to write comments clearly. Then in yellow, there should be green. And accordingly, you change it here everywhere, wherever that is green, red, or blue, that is yours. And we have to start it, the same code. First it's glowing red, then it's glowing blue, then it's glowing green. RBG. All three are getting to get on, right? Now, with this, all 3 experiments are getting completed. Now you have some take home also. Take home means you have to use 6 LEDs. Like you have to use 6 LEDs. 1, 2, 3, 4, 5, 6. There should be 6 LEDs. And those 6 LEDs should be chasing each other. Means first LED is getting on, off. Once it is getting off, another should start. Once it is getting off, another. And the same way, it should repeat as well. And you have seen the police lights, no? That light goes and comes, goes and comes. So the same way you have to make the same setup with 6 LEDs. I hope it's very clear to you. It will be easy. All the best for your assignment. Thank you.